All right, folks, today we're going to finish talking about the unit circle. On your homework, you had a couple problems dealing with special triangles. That was intentional because we're going to use our special triangles from geometry on the unit circle today. So as a reminder, the two special triangles that you need are the 30, 60, 90 degree and the 45, 45, 90 degree. With those special triangles, the same side pattern appears every time. I'm going to start with the isosceles triangle. When you've got two angles the same, two sides are the same, you've got 1, 1, square root of 2. And then over here with the 30, 60, across from that small angle is the number 1. Hypotenuse is 2. And across from the 60 degrees, our longest leg is radical 3. Now, in geometry, you may have learned these a little bit differently. It may have looked like x, x, and then x square root of 2. And this one, it could have been x, 2x, and then x square root of 3. Because when we're talking about the 1, 1 square root of 2, it's the reduced version. It's the pattern of the sides, how they work. So on our isosceles triangle, from here to here, you multiply whatever your number is by square root of 2. On this one, same thing kind of happens. From your smallest leg, you multiply to get to the hypotenuse, this time by 2. And then on the long leg, you get there by multiplying by the square root of 3. So it's all dependent on this short leg. So hopefully those are familiar to you from geometry. What I need you to do is write down that pattern on your class practice sheet because we're going to use those patterns over and over today. Okay, but I want to talk about how it related to what you saw actually on your homework. So the only difference on your homework that you saw is they attached some labels, and I'm going to just do it for this 45, 45. And in the reading, they gave you that the AB length was 1, and your job was to find these other. We can use the pattern to solve for those other sides, even with this being the only information we're given. So here you'll notice I talked about going this direction from 1 to the square root of 2. You just multiply by the square root of 2. If I need to go backwards the other direction, it just means divide by the square root of 2. So if I'm given the hypotenuse, I just divide by the square root of 2, and then we know we can't have that square root symbol in the denominator, so then we would rationalize, leaving us with the square root of 2 over 2, and because these are isosceles, that would have to be the length of the bottom side as well. Okay, similarly over here, we could do the pattern using knowing our hypotenuse is 1. So from here to the short leg, we would divide by 2 this time, not square root of 2, based on this pattern. So no need to change that one. And then from here to here, you multiply by radical 3, so this would be 1/2 times the square root of 3. And this just looks a little bit funny, so a lot of times it'll be written the square root of 3 over 2 instead. Now, why these triangles are important is entirely based on that hypotenuse being 1. What we're going to talk about is how these can represent points on the unit circle. So if I take, you'll notice I added extra points on the unit circle from the 4 that we learned last time. If I take and just pick on 1, I could take that point, connect it to the origin, take that point, connect it down to the x-axis, and form a right triangle. And that hypotenuse would have to be 1 because this was the unit circle, and we know that the radius of the unit circle is 1. A radius in a circle can be drawn any direction. It does not have to be our standard horizontal or vertical piece. So then, if this is my 30-degree angle by chance, then I know that I can work through this problem, sine, cosine, and tangent, using what I learned last time. Now, I told you last time that these points were represented by cosine of the angle that gets you there, in this case, cosine of 30. Oops. And similarly, the sine of the angle that gets you there, again, in this case, 30. Okay, and we're going to use our geometry skills to go find that answer. Okay, not on this picture, but just sine of 30, what we learned before. So with our special triangle, that'd be 1, 2, square root of 3. And if I wanted the sine value from SOHCAHTOA, that would be the opposite over the hypotenuse, so this part would be 1/2. Cosine of 30 degrees, that's the adjacent over the hypotenuse, so that would be square root of 3 over 2. Okay, but I'm going to relate this back to what we've been talking about in terms of that homework, special triangles, and the unit circle. We just decided that this cosine of 30 degrees was radical 3 over 2. And from this, that denotes this x length along the bottom of our ordered pair. Let me go ahead and change colors there. Okay, that distance. This 1/2 is represented by this distance. So if I go back to the picture that we were just talking about, if you'll notice the sides here, the 1/2 was going up and down, the square root of 3 over 2 was going there. It's just changing our normal SOHCAHTOA triangle that we're used to seeing and making the hypotenuse 1 to standardize it for fitting inside of this unit circle. The nice thing about this is when we're talking about standardizing it, getting to 1, the pattern stays the same. So if the pattern stays the same, there's really no reason for us to get this one. We can actually use the original triangle without having to work too hard. So when we go through here, we know SOHCAHTOA as opposite over hypotenuse. Just to kind of compare it to what we did last time, we got to remember that when we're in the unit circle, that hypotenuse is 1. That says sine is the opposite side. So last time when I told you sine was y, it's because y is giving you the distance opposite of the angle. So now we know why that's working. Okay, before we didn't have triangles to work with, so I couldn't really show you that. Similarly, when we have adjacent over hypotenuse, our hypotenuse is 1. It's just the adjacent side. So it's just the x value. And tangent, we know, is opposite over adjacent. I showed you that was equal to sine over cosine. And I did it using opposite over hypotenuse being over adjacent over hypotenuse. And I showed you those h's cancel out, but we can also say that hypotenuse is 1. The O over A comes from there as well. Okay, so the relationship is directly identical. We're going to practice how we use it. Okay, so now on your practice sheet, we're given sine, cosine, tangent of values that are no longer at the 4 points on the unit circle. They're somewhere else. Okay, we're not actually going to draw the unit circle anymore. We're going to draw triangles that represent the angle that we're given. A lot of these problems are going to be in radians, so we need to be able to recognize radians not only as where they would fall based on just the fraction, but also what the reference angle, or that angle in the corner that we were drawing, would have to be. So to start out with, what we're going to do is figure out what these 3 things are in degrees, because these are the fractions that are going to show up most commonly in radians. Okay, if we remember that pi stands for 180 degrees, 180 divided by 3 is 60. So pi over 3 just represents 60 degrees. 180 divided by 6 is 30, so this is 30 degrees. And 180 divided by 4 is 45. Okay, those are important because they're their special triangle angles that we were just talking about. So this says negative pi over 3. It really means negative 60 degrees. What we're going to do is just imagine our circle, not draw it, and then put the point going clockwise 60 degrees that would land on your circle. So ours here would be about there for 60 degrees. And we're not drawing this circle just because it complicates our picture, makes it too messy. What we are going to do is make a triangle out of this point. You're going to connect this point you just drew to the origin and to the x-axis always. With that x-axis is always going to be a right angle box. And then in this corner, we decided this was 60 degrees. From there, we're using our special triangles to fill out these side lengths. So across from the 60 is square root of 3 in the special triangle. Okay, the hypotenuse is 2, and across from the 30 is 1. Okay, the last step on our picture is fixing the signs. So we're going to make ourselves a note here. What you're going to do is start at the origin and get to that point. We have to go to the right, that's positive, and we have to go down, that's negative. Hypotenuse will always be positive. Leave it alone. Okay, so once we have our signs attached, we use SOHCAHTOA to answer the question. So is what's happening here. So opposite over hypotenuse is negative square root of 3 over 2, and we're done. Now just to convince you this is working how it's supposed to, I'm going to type this in. I have this already in degrees, so I'm going to keep it there. Sine of negative 60 is this ugly decimal, and I'm going to type in this negative square root of 3 over 2. And I missed my negative, so just matching it negative, and you'll notice those numbers match. Okay, so this is the exact version, which is what it's asking for. All right, next up, same process. We're going to figure out where this would be, and we're going to go back to kind of what we were thinking about last time. Remember, over here is pi. So this says 3/4 of pi, so I'd go over 3/4 of the way and draw my dot. From there, we're going to connect it to the origin and the x-axis to make the right triangle. Okay, but this angle in the corner comes from those fractions that we were talking about. Ignore that 3, just care about what's on the denominator. We know this pi over 4 goes with 45 degrees, and that's how you'll decide the angle in the corner, every time. Okay, from there, we put our side lengths on from our special triangles. Since this is a 45/45, we've got 1, 1 square root of 2. Next step is to do the signs. So from the origin, we get to the dot by going left, negative, up is positive, leave the hypotenuse alone. Cosine with SOHCAHTOA is adjacent over hypotenuse. So from this angle, adjacent is next to it. Hypotenuse over here, we want negative 1 over the square root of 2. This is one of those ones that we'll have to rationalize because we can't have that radical in the denominator. So just multiply by the square root of 2 over square root of 2. Straight across, we've got negative square root of 2 over 2. And we'll get to a point where we see this and know the final answer without having to write down that step. Okay. Next up, it says cosine of 30. There's no radians involved, so we'll just draw 30 degrees. Okay, we know that's in quadrant 1. And we'll make it into a triangle. Because the angle is given to us, we just throw it in the corner, no worries. And we're putting on our side lengths. So 30, 60, 90, we've got 1, 2, square root of 3. Use your pattern that you see, but you got to love and know it. And then put your signs on there. From the origin, right is positive, up is positive. Okay, we want the cosine, which is adjacent over hypotenuse. So from this angle, always at the origin, adjacent is right next to it. Hypotenuse is across from the right angle. We've got the square root of 3 over 2. All right, 2/3 pi here. So again, here's pi. 2/3 would be almost to it, 2/3 of the way to it, right a point. Make it a triangle. Okay, from there, we got to put the sides on, knowing that pi over 3 is 60 degrees. Okay, again, you can think that through because pi is 180. 180 divided by 3 is 60. Okay, the 2 is what got us to that quadrant. Okay, we just need to know that part. From here, we've got square root of 3 across from the 60 always, 2 across from the right angle, and 1. If you're struggling remembering where things go, remember there's always a 2 in the hypotenuse. Okay, that goes for both special triangles. This one's a regular 2, and the other one's a square root of 2. Okay, but we got to pay attention to signs. We're going left and we're going up. So that's negative and positive. Again, we're imagining this on the unit circle. It's not actually on the unit circle because we didn't change this to 1. Okay, but that gives you an idea of what these signs actually represent. When we're thinking sine is y, in this quadrant going up, it should be positive from what we were talking about last time. Okay, so that's kind of what we're relating this to for these problems as well. But we want opposite over hypotenuse. So from this angle, opposite hypotenuse will end up with a positive square root of 3 over 2. Okay, you'll notice that these fractions are showing up over and over again. Okay, kind of like when we were talking about the original 4 points, there were only so many options. Same thing with sine and cosine on your special triangles. We're either going to have 1/2 show up, or we're going to have this radical 3 over 2 show up when we're dealing with the 30, 60, 90. Okay, when we're talking about a 45, 45, we saw that a square root of 2 over 2 shows up, and that's the only option for it. Okay, let's talk about degrees. So on number 5, we've got 240 degrees, and it's not in quadrant 1. You're not going to have a triangle that has 240 in the corner. Okay, I'm going to draw a visual for that for you. Okay, if I draw some triangle, it's impossible for this to be 240 degrees, so we can't do that. Okay, the process stays the same. We want to figure out where 240 lands first. Okay, so this I'm calling 180 instead of the pi because we're dealing with degrees. And I know this was my 270, so it's got to be between these. Just pick a point and draw it in. Okay, it doesn't matter if it's accurate because we're going to fill out this triangle based on the angle we put there. We're saying that this is 240 degrees, and if I care about this angle here, then I care about the difference between those two values. I don't need this 270. Remember how I told you that this right angle is always on that x-axis? We're going up always, or we're going to the x-axis. Okay, with that, same thing here. We're always going to compare it to the number at the horizontal piece. We won't use those. With that in mind, we're going to take 240 minus 180 to get there, and that is 60 degrees. Okay, from there, same process as before. We fill out our sides. Radical 3 is across, 2 is hypotenuse, 1 here. And then we go from the origin, left and down would be negative and negative, to fill out our final answer. So for SOHCAHTOA here, we're going to have opposite over hypotenuse being negative square root of 3 over 2. Alright, I want you to pause the video and take care of those last couple problems for me, please. Okay, if you struggle at all, I am going to go over them step by step. Okay, but pause the video and try each of them first. This one is clockwise, 45 degrees. Okay, because of the over 4 that we talked about before. 45, 45 has 1 square root of 2. And I'm going right and down, positive and negative. Okay, with that, we want the cosine, which is adjacent over hypotenuse. That's 1 over the square root of 2. And that's rationalizing to square root of 2 over 2, as we talked about before. Next one's a little bit tricky to find, like where it's located on a picture, but mixed numbers help us with this. So if we change this, 6 goes into 17 2 times with 5 left over. So this is 2 pi with 5 6 pi left over. I know that 2 pi is here and 1 pi is here. I go full way around 2 pi and 5 6 another lap around. So there's my triangle, and I'll redraw it so it's a little bit bigger. And because of this 6 here, I know this is 30 degrees. Okay, from there, as we go through and put our numbers on there, 1, 2, square root of 3, and our signs, negative, positive, we end up with our sign, opposite over hypotenuse, being a positive 1/2. Okay, the same thing goes in terms of a problem like number 8. If you struggle figuring out where this is, draw on your picture with your numbers, okay? So here, I know that 1 lap around is 360. I know I can go another lap around, 720. And if you didn't know that automatically, you just take and you add them up the old-fashioned way, okay? And then I know a third lap around is 1080. Again, if you don't know that, you would tack on another 360 because we're doing this out of calculator. Okay, and this number is not quite to 1080. So I'm going clockwise, and I'm going 1 lap around for sure, 2 laps around for sure, but not quite to 3 laps around. I know it's close, so it will be in this first quadrant since I'm going clockwise. Now, because it ends in a 5, there is only one special triangle with a 5 for an angle, and that is 45 degrees. Okay, so when you see this 5, it has to be a 45 triangle. No other option. With that, 1, 1, square root of 2, and everything is positive in quadrant 1. Okay, but positive, positive. And cosine wants the adjacent over hypotenuse, positive square root of 2 over 2. Alright. Number 9, 10, and 11, the only thing new on them is tangent, so we're just going to do 10 and 11. We won't do number 9. Okay, so a negative 11 force means we're going clockwise. And again, change this to a mixed number to help us here. Okay, so 4 goes into 11 2 times with 3 left over. So this is a negative 2 3/4 pi. So writing on our picture, there's 2 pi, there's 1 pi. And I'm going clockwise, remember. So here is 2 pi, 1 time around. And then negative 3/4 would be here in quadrant 3. Now because of this over 4, this is a 45 triangle. So 1, 1, square root of 2 are my sides. I just have to attach the signs. So from the origin, going left, negative, going down, negative, we can answer these questions. Sine is opposite over hypotenuse, so that's the negative 1 over square root of 2, so negative square root of 2 over 2. Cosine is the adjacent side over the hypotenuse, looks exactly the same, negative square root of 2 over 2. And the tangent is opposite over adjacent, so this one's new. We take the opposite side, negative 1, over the adjacent side, negative 1. It ends up being 1. And just to kind of tie that into what we did last time, don't forget that tangent was sine over cosine. When I take this fraction over that fraction, it looks exactly the same on top and bottom, reduces to 1. Alright, so now that you know the setup for that, I want you to pause the video and try 11, tangent included. Negative 5, 6 pi should have been also in quadrant 3, but this time we've got a 30-degree angle showing up. 1, 2, square root of 3 for a 30, 60, 90. And with this, negatives again. Sine would have been negative 1/2. Cosine negative square root of 3 over 2. And our tangent ended up being a new fraction to rationalize. It was opposite over adjacent, being negative 1 over negative square root of 3. So first thing I'm going to do is just get rid of those negatives. Okay, but then to rationalize this thing, instead of multiplying by our square root of 2, we're multiplying by the square root of 3. So we end up with the square root of 3 over 3. The only other thing we need to talk about today is going the other direction. Okay, so sometimes these are more challenging, but we just have to make sure we're reading all of the instructions to be clear on what it's asking for. It says find all value of theta. That means solve for the angle. Okay, and it says between 0 and 2 pi, so that means solve for the angle in radians rather than degrees. And here's what we're solving the equation of. It says sine theta equals negative 1/2. We're going to draw a picture to do this based on what we just talked about. So from last time, we talked about with this, we can classify that as y being negative. Same kind of concept. They don't say less than 0, they give you a specific value, but we still want to find the part of this graph where that's even possible. So y is negative down below. Because it's a specific number and not a less than something, we don't want the whole quadrant. We want specific places on the circle or specific points. So what we're going to do is, I know it's either here or here, we're going to put a dot in both of those to represent our options. And we're going to make triangles out of both of those. So the first one, to the origin, to the x-axis, The second one, same thing, to the origin, to the x-axis, and you can see your right triangles. Okay, but what's different here is they don't give you the angle. Instead, they give you the side ratios. Sine is opposite over hypotenuse, so this fraction is representing that. So from our angle, always at the origin, the opposite side gets to be the 1, and the hypotenuse gets to be the 2. You can do it on both triangles. Technically, you only need 1. And I left out that negative because we have to look at our picture to decide which piece is negative. So here, going to the left, going down, the 1 is the piece that gets negative. It's not always the top number, so be careful. Now that we know that, we can fill in our third side. This is a 1, 2 square root of 3. Again, this one would be negative, this one positive, but the goal is the angle. So we're supposed to look at this special triangle and figure out what the angle is. Because it's 1, 2, and square root of 3, it's a 30, 60, 90 triangle. And because the 1 is across from the angle in the corner must be 30 degrees. What you're going to do to begin with here is, because it's 0 to 2 pi, and we drew 2 places going counterclockwise, there are 2 answers. Because it says 0 to 2 pi, we have to have radians in our answer. I know it's going to be something with pi. And I know one more thing. Because this was 30 degrees, I know that my answer has to be over 6. Those go together. So that's what we're starting out with. Okay, but also, we can figure out what this answer is from the beginning all the way down really quickly using this pattern. Here's how it works. Because I'm in radians, I'm going to put a pi here and a 2 pi here. And I know 30 degrees is really 1/6 pi. So if this is 1/6 pi, I'm going to call this 6 over 6. To get from 6/6 to 1/6 more, I just have to add that down. Okay, so this one is 7/6 pi. Going all the way around, the closest thing to this point is the 2 pi. Again, this is 1/6 pi. So I'm going to change this to something over 6. And I want to divide to get 2. That's 12 over 6 gives you 2. So it's almost to 12, but it's 1 less. That would be 11/6 pi. And that's it. Okay, number 13 is the same process. Okay, we're going to go ahead and set up our problem based on this sine value being y and this being positive. You may write yourself a note. You're doing sines first. And then the second thing you're going to do is figure out what kind of triangle it is. And that's using your like SOHCAHTOA stuff. And then your third step is fill in the angle based on that stuff. Use those instructions to draw your triangles for me. We're going to talk about the final answer together. Alright, so sine is positive in the first quadrant and the second quadrant. This is opposite, so radical 3 goes here and 2 goes on the hypotenuse. Again, you can fill out both triangles, but you technically only need one, because the goal is not to find this side. I don't even care if this has a -1 on it. The goal is to find the angle. So the angle comes from your sides and your special triangle, and this would have to be 60 degrees since it's across from that radical 3. With that in mind, we're going to talk about our answer. So this one, it says go -2 pi to 2 pi. That just means go both directions, clockwise and the regular. We're going to do the regular one first. Okay, I told you last time our answers have to be in radians, and because this says 60 degrees, this is 1/3 pi. So I know something over 3 pi has to be my answer, and something over 3 pi has to be my answer for the second one as well. So here, it's just literally the 1/3 pi to get me there. Over here, I just have to work a little bit more. Remember, put over here your pi and your 2 pi. And because it's over 3, we would call this 3/3. I'm not quite to 3/3. I have to go backwards. And because this was 1/3 pi, I'm just going backwards by 1, this would have to be 2/3 pi. Okay, for the second part, we go the other direction. Okay, so what we're going to do is put negative something over 3 pi, negative something over 3 pi, because I know that's what my answer has to look like. And then we'll find the something. So now I'm going this direction. This time I'm past 3/3 by 1. I have to go past that pi right there. So this time I'm adding and getting 4/3 pi for that one. All the way around, I use the thing closest to it, so I'm going to use 2 pi here. And I'm changing it just like I did the last one, something over 3. This time I need to get to the number 2, so it has to be 6/3. But I haven't gone all the way around, so I'm not quite at 6/3 pi. I have to backtrack by 1. So the last answer is 5/3 pi. You are welcome to do these problems in degrees if you want. So like this, it was 60 degrees. 60 degrees. Here I know my first answer is 60 degrees right there. Here I'd take 180 minus 60 is 120. This direction, 180 plus 60 is 240. Okay, negative, going clockwise. And then all the way around, I'm not quite to 360, I'm 60 short, so 300. But the problem with this is the instructions still have to have a final answer of radians. So if you want to work in degrees because your brain just likes that a little bit better, you have an extra step to convert all of those to radians after the fact for the final answer. Good news is, once you decide it's 60, you know the formatting has to have pi and over 3 in all of your answers. Okay? If you struggle on any of those, especially these ones working backwards, please come in to see me and get some extra help.